Hi guys, welcome to today's video. Grade 11 trigonometry, sine, cosine and area rules. Should be a relatively long video, so without further ado, let's get to it. We're going to look at three subsections, that is the area rule, the sine rule and finally the cosine rule. First, there are three identities related to trigonometric functions that simplifies calculations related to triangles. That is the area rule, the sine rule and finally the cosine rule. First, let's look at the area rule. For any triangle ABC with side AB is equals to C, side BC is equals to A, and side AC is equals to B, we can construct a perpendicular height H connecting point A with line BC. And now we're going to go in and prove the area rule. If you look at triangle ABC, you're going to notice that sine of angle B is equals to H over C, that is opposite divided by hypotenuse. And if you look at triangle ABD, the opposite of that triangle is H and the hypotenuse is C, as you can see. And now making H the subject of my formula, I'm going to have H is equals to C multiplied by sine of B. And we know that area of triangle ABC is equals to half of base multiplied by height. And the base of that triangle is A and the height is H, and hence we're going to have 1 over 2a multiplied by c sine of b, because we've already proved that h is equals to c sine of b. And hence, area of triangle ABC is equals to half a multiplied by c sine of angle b. And if you inspect that triangle or that certain formula, you're going to see that the area rule deals with two sides and an angle in between them. This time the sides are a and c, and the angle in between is angle b. Now let's move on. Alternatively, we can say in a triangle ABC, sine of angle C is equals to H over C. This time around, we're no longer looking at angle B, we're looking at angle C, and hence the hypotenuse and the opposite will have changed. The opposite rather is still the same, is H, but the hypotenuse this time around is B. And hence again, making H the subject of my formula, I'm going to have H is equals to B sine of angle C. And I know that area of triangle ABC is equals to half base multiplied by height, and the base is still A, but now I'm going to express the height in terms of B as opposed to C, as I used in the previous example. And to do that, I'm going to go on and say area of triangle ABC is equals to 1 over 2 AB sine of angle C, and that is the area rule again. And if you can see again, this time the sides are side A and side B, and the angle included is angle C, as you can see. And similarly, we can construct perpendicular height H connecting point B with line AC as shown below. And we know that area of triangle ABC is equals to 1 over 2 BC sine of A in this particular example. And hence, the area rule states that for any triangle ABC, area of triangle ABC is equals to 1 over 2 BC sine of A, or area of triangle ABC is equals to 1 over 2 AC sine B, or area of triangle ABC is equals to 1 over 2 AB sine of angle C. And again, if you observe that, or if you observe those three formulas, you're going to see that we are dealing with two sides of a triangle and an angle in between them. Now, let's take a look at an example. Exercise 1. In triangle XYZ below, XZ is equals to 15, YZ is equals to 21, and angle Z is equals to 51.8 degrees. Find the area of the triangle. I'm going to go on and say area of triangle XYZ is equals to 1 over 2 XZ multiplied by YZ multiplied by the sine of the angle in between them, which is angle Z in this case. And substituting in my values, I will get area of triangle XYZ is equals to 1 over 2 15 multiplied by 21 multiplied by the sine of 51.8 degrees, and that will give me an area value of 123.77. Let's take a look at another example. In triangle PQR below, Q is equals to 8, P is equals to 6, and the area is equals to 15.5. Find the value of angle R. This time we're given two sides and the area, and we're asked to find the angle. First step, again, I'm going to write down my area rule. That is half of two sides multiplied by the sine of the angle in between them. That is area of triangle PQR is equals to 1 over 2 P multiplied by Q multiplied by sine of angle R. And substituting in that, I will have 15.5 which is my area, is equals to 1 over 2 multiplied by 6 multiplied by 8, which are my sides, multiplied by sine of angle R. And simplifying that a little bit further, I will get 15.5 is equals to 24 sine of angle R. And making sine R the subject of the formula, I will have sine of angle R is equals to 15.5 divided by 24. And making angle R the subject of the formula, now I'll have sine of R, or I will have angle R is equals to arc sine of 15.5 over 24, and that will give me an angle of 40.23 degrees. Now let's take a look at the last example under this section. In triangle ABC below, AC is equals to 10, angle C is equals to 20.5 degrees, and the area is equals to 26.9. Find the length of the side BC. This time around, we're given one side, one angle, and an area, and we're asked to find the second side. Again, I'm going to go on and write area of triangle ABC equals 1 over 2, the product of two sides of a triangle and an angle and the sine of an angle included, that is 1 over 2 AC multiplied by BC multiplied by sine of angle C. And substituting in my values, I will have 26.9, which is my area, is equals to 1 over 2 multiplied by the 10, that is one side that is given, multiplied by BC, that is what I'm trying to find, is multiplied by the sine of 30.5 degrees. And simplifying that a little bit further, I will have 26.9 is equals to 5 multiplied by BC multiplied by sine of 30.5 degrees. And again, simplifying a little bit further, I will have BC is equals to 26.9 divided by 5 multiplied by sine of 30.5 degrees, and that will give me the side of the length 10.6, and hence BC is equals to 10.6. Now let's move on to the sine rule. For the sine rule, for any triangle ABC with AB is equals to C, BC is equals to A, and AC is equals to B, we can again construct a perpendicular height H at D. Let's look at triangle CAD, and we'll notice that sine of angle A is equals to opposite over hypotenuse, which is equals to H over B. And making H the subject of the formula, we'll have H is equals to B sine of A. And in triangle BCD, again, sine of angle B is equals to H over A, and again making H the subject of the formula, H is equals to what? A sine of B. And now, both heights are the same. That height is a common height, and hence we can equate the two formulas to have B sine of A is equals to A sine of B, because the first H is equals to the second H, and hence B sine of A is equals to A sine of B. And dividing both sides by AB, I will have sine A over A is equals to sine B over B, or we can flip it around and go on and say A over sine A is equals to B over sine B, and that is the sine rule. Similarly, by constructing a perpendicular height from point A, we can also show that sine C over C is equals to sine B over B. Or again, we can flip it around and say C over sine C is equals to B over sine of B. Okay, now that we've proved the sine rule using trig ratios, we can now move on to proving the sine rule using areas. We know that area of triangle ABC is equals to 1 over 2 CB sine A from the area rule previously proved, and again area of triangle ABC is equals to CA sine of B, again from the area rule previously proved. Now, both those two areas are equal because it's the same triangle, and hence I'm going to go on and equate them. 1 over 2 CB sine of A is equals to 1 over 2 CA sine of B, and the halves are going to cancel. 1 over 2 and 1 over 2 will cancel out. The C and the C will cancel out, and that's going to leave me with B sine of A is equals to A sine of B. And again, dividing both sides by AB, I will eventually have sine A over A is equals to sine B over B, or A over sine A is equals to B over sine B. So according to the sine rule, for any triangle ABC, sine A over A is equals to sine B over B is equals to sine C over C, or flip it around, A over sine A is equals to B over sine B, is equals to C over sine of C. Now let's take a look at an example. Example 1. In the diagram below, angle A is equals to 31 degrees, angle B is equals to 45 degrees, and AC is equals to 34. Find the length of BC. I'm going to go on and say sine of A over A is equals to sine B over B. And now substituting in my values, I will have sine of 31 over BC is equals to sine of 45 over 34, and making BC subject of the formula of first cross multiplying, I will have BC sine of 45 is equals to 34 sine of 31, and making BC subject of the formula, I'm going to divide both sides by sine of 45 to have BC is equals to 34 sine of 31 divided by sine of 45. That will give me the length of BC, which is equals to 25,21. Now let's take a look at the next example. In the diagram below, QR is equals to 11 centimeters, PR is equals to 8 centimeters, and angle P is equals to 65 degrees. Find the value of angle Q. Again, I'm going to go in and write my formula. Sine P over P is equals to sine Q divided by Q. Sine of 65 degrees over 11 is equals to sine of Q divided by 8, and cross multiplying, I'll have 11 sine Q is equals to 8 sine of 65, and making sine of Q the subject of the formula and dividing both sides by 11, I will have sine Q is equals to 8 sine of 65 divided by 11, and again making Q the subject of the formula. Q is equals to arc sine of 8 sine of 65 divided by 11. That will give me a Q angle of 41,23 degrees. And now let's move on to the cosine rule. In the diagram below, AB is equals to C, BC is equals to A, AC is equals to B, AD is equals to X, and DB is equals to C minus X. We can construct a perpendicular height H. And if we look at triangle BCD, we're going to notice that A squared is equals to H squared plus C minus X squared from the Pythagoras theorem. And making H squared the subject of the formula, we'll have H squared is equals to A squared minus C minus X squared. And now if we now look at triangle CAD, we're going to notice that B squared is equals to H squared plus X squared, again from the Pythagoras theorem. And again making H squared the subject of the formula, we'll have H squared is equals to B squared minus X squared. And now I'm going to equate the two equations because the H is still the same, and hence the H squared is still the same. It's the common height. That will give me A squared minus C minus X squared is equals to B squared minus X squared. The first H squared is equals to the second H squared. And simplifying that a little bit further, A squared, I'm going to write it as it is and expand the C minus X to give me C squared minus 2CX plus X squared is equals to B squared minus X squared. And again simplifying and making A squared the subject of the formula, I will have A squared is equals to B squared minus X squared plus C squared minus 2CX plus X squared. And if you look at that, the negative X squared plus X squared will minus each other out, and that will leave me with A squared is equals to B squared plus C squared minus 2CX. And now I'm going to try and get rid of the X because it's not really part of my larger triangle. I'm only interested in sides A, B, and C, and it will be very lovely to make my formula in terms of only those and their angles. Now, we have shown that A squared is equals to B squared plus C squared minus 2CX. We need to now eliminate the X, and hence we need to represent it in different terms, in terms of A, B, and C, because those are the larger or the main parts of my triangles, or the sides that make up my larger triangle, not the smaller ones. And to do that, I'm going to go on and say in triangle CAD, cos of A is equals to adjacent over hypotenuse, which is equals to X divided by B. And making X subject of the formula, because the one I'm trying to eliminate, I will have X is equals to B cos of A. And I'm going to go on in my first formula there, or the formula that I've taken with me this far, which state that A squared is equals to B squared plus C squared minus 2CX, and substitute out the X with B cos of A. I will now have A squared is equals to B squared plus C squared minus 2BC cos of A. And that proves the cosine rule. So according to the cosine rule, for any triangle ABC with AB is equals to C, BC is equals to A, and AC is equals to B, A squared is equals to B squared plus C squared minus 2BC cos of A. b squared is equals to a squared plus c squared minus 2ac cos of b. And lastly, c squared is equals to a squared plus b squared minus 2ab cos of c. Now let's take a look at an example. Example 1. AC is equals to 7 centimeters. AB is equals to 10 centimeters. And angle A is equals to 55 degrees. Find the length of side BC. Again, I'm going to go on and write my formula for the cosine rule. A squared is equals to b squared plus c squared minus 2bc cos of A. And substituting in what I know so far, bc squared is equals to ac squared plus ab squared minus 2ac ab cos of A. And substituting in the values now, I'll have bc squared is equals to 7 squared plus 10 squared minus 2, 7 multiplied by 10, multiplied by cos of 55 degrees. And that will give me bc is equals to square root of 7 squared plus 10 squared minus 2, 7 multiplied by 10 multiplied by cos of 55 degrees. And that will give me bc value of 8.29 centimeters. Now let's take a look at the next example. Find the value of angle Q in the triangle below. We are given the lengths of all three sides of a triangle. And again, I'm going to write down my cosine rule. Q squared is equals to p squared plus r squared minus 2p multiplied by r cos of angle Q. And substituting in now my values, I'll have 11 squared is equals to 8 squared plus 6 squared minus 2, 8 multiplied by 6 cos of angle Q. And simplifying that a little bit further, we'll have 121 is equals to 64 plus 36 minus 96 cos of angle Q. And again, simplifying a little further, we'll have 121 is equals to 100 minus 96 cos of angle Q. And making now 96 cos Q the subject of the formula, we'll have 96 cos Q is equals to 100 minus 121. And that will give me 96 cos Q is equals to negative 21. And dividing both sides by 96, I will have cos of angle Q is equals to negative 21 over 96. And now making Q a subject of the formula, I will have angle Q is equals to arc cos of negative 21 over 96. And that will give me angle Q value of 102.64 degrees. Now that we've shown all three area, sine, and cosine rules, let's take a look or observe what we can conclude so far from the three rules. Now, how do I know when to use which rule? First, we're going to look at the area rule. You use the area rule when obviously, when you're given the area of the triangle. That is usually a good hint that you should use the area rule. And when no perpendicular height is provided, that is again another very good clue to use the area rule. Next, let's take a look at when to use the sine rule. You use the sine rule when no right angle is present. That is the first condition. The second condition is when two sides and an unincluded angles are known. Unincluded, that is very important. The angle doesn't have to be included between the given sides. And thirdly, if two angles and a side are given, again, that is a pretty good clue that you should use the sine rule. And now let's take a look at when to use the cosine rule. Again, first, when no right angle is present. And the second condition, two sides and the included angle are known. And lastly, all three sides are known. That is a pretty good clue again to use the cosine rule. And that brings us to the end of this lesson. Thank you for joining me. And if you've made it this far and you found this video helpful, please consider liking the video and subscribing if you are new to the channel. And please do comment below on which chapters do you want me to cover next. For now, thank you and take care.